Welcome to our maths lesson, and today I want you to focus on what we call distance time graph. Let us put our concentration on a graph. We have looked at speed, we've looked at calculations, we've been able to look for distance given time and speed, look for speed and so on. This time round we want to plot a graph, and this is what we call the distance time graph. Now, this can be illustrated in various ways, among others. So when you talk about a graph, what comes in your mind? Slightly to put across, what comes in mind is something like this. Such that before you start doing anything, you have not started the journey, you are at zero. You have covered no time, neither have you covered any distance, so you are at zero. The moment you start moving at a certainly average speed, I'll say, then it follows that there will be some movement to a certain part. Let me call it D1. If you choose to rest here, maybe you are attending on something, the graph will be horizontal. You talk of a horizontal graph when you are either resting or you've stopped. But you see, you are covering no distance, but time is elapsing. So you can reach there, then after your errands, you choose to continue with your journey again. When the line is moving and it is straight, and it has got a certain gradient, then it's telling us that there is a constant speed being maintained. So you can move, you reach a point, and you take another rest, maybe for lunch, and it goes on. When you start coming back where you came from, you'll start coming back like this, of which you can choose to rest and finally end your journey. This is what we call a distance time graph. Distance time graph, we are supposed to use the graph, interpret the graph, and describe the journey that someone covers or someone drives given the graph that we have. Alternatively, if we have the description of the journey, we should be able to come up with a graph. I want us to look at a few situations which can be described on a graph. Now, we have a situation here. Ella walked from the back of the room, stopped for a short time, then turned around and walked back to the room again. Now, this information, we want to put it on a graph. Our graph should have the vertical distance, the vertical axis, which we call what? The distance, distance traveled, and the horizontal distance, horizontal axis, we give it time. So Ella, before starting to walk, was at a stationary point, having covered no distance and having covered no time. This Ella walked to a point and then stopped for a while. So the graph this is average walking. It moves on and on and on. And then reaching here, stopped for some time. So there's no movement taking place. There is stopping. And then now, when this Ella reaches there, decides to go back to the room, so the graph will drop. In this graph, we are seeing that Ella walked to cover a certain distance. Let me call it here, D1. So having covered the distance D1, he rested from time T1 to time T2. You see, between T1 and T2, nothing is taking place. There is some resting. Ella is resting. So this part here, there is resting. And then walked back at a certain speed. That's why we have a constant gradient. So when we talk about a gradient, it means a lot when we are referring to distance-time graph. Gradient gives us the speed. Gradient tells us if a body is at stationary or not. Gradient will always tell us what is the behavior of the object traveling. So we have many other situations. If you look at this situation, it is describing the movement by Ella to the room, resting, then turning around and going back to the room. Let us look at another situation and interpret. So, Jasmine walked from the front of the room to the back of the room, where she stopped for a short while or short time. Then she turned and walked to the front of the room. So we have two areas here. We have the front and we have the back. We have the front and we have the back. So if we have our graph starting from front to back, we should be careful about that. If we have our graph reading back to front again, we should be very careful on how we handle that. So if we choose to have it that the situation here, we have our graph, and then we choose this part to be our front. And the part down here where we have the origin to be the back, right? So that we have time there, and then here we have our distance traveled. So we are looking at Jasmine starting to walk from front. From front. So if Jasmine walked to the back, then we'll reach this line. If not, it will hang. So Jasmine walked from the front of the room to the back of the room. Take note of that. From front to the back. So I'll expect you to have your graph starting from the front all the way constantly until the back. Having reached the back, she stopped for some time. and then turned and walked to the front again. Then somewhere there. So you see, we have our distance time graph showing us where we have the front. It is also showing us where we have the back. When Jasmine walked from front to the back, the line here should touch the axis because the axis is the back. If it was just a certain distance, we would stop in between here. So you see, it started from front to the back, rested, and back to front. Let us look at another situation and see how different the graphs will be. And we are looking at front and back. Now, there is a different situation. We are still considering a room. And when we talk about a room, I want you to look at where you are seated, right? Where you are seated. If you are seated at the back, when I say from back to front, it's from where you are at the back to where I am, assuming I'm in front of you, and then you are at the back. When you walk to the front here, you have made a distance. You stop for some time with us. So those are the things we are trying to show out here. So there is a guy called Lucas who walked from the back of the room to the front, then stopped for a short time, and then turned and walked halfway to the back briefly. Halfway to the back briefly, to the back, then briefly stopped and then turned again and walked to the front. Look at that. So our illustration in a graph, we are going to have the front and the back. I've said ours here is the back and this is our front, right? So Lucas walked from the back of the room to the front and stopped. So I'll expect to start from the initial point to the front. See that? Stopped for some time, for a short time, and he then turned and walked halfway. Turned and walked halfway to the back. Briefly stopped, so there's a brief stop there. And then turned again and walked to the front. Turned again and walked to the front. So illustration here is telling us that there is a rest here. Now, this one here is when moving forward. This is when moving backwards. When moving back to the starting point. And again, we're going forward to the front. So the end where we have the front is here. This is the start of the journey. So there was a constant speed maintained here. Then there was a rest of some time, and then there was a constant again walking back, stopped for some time, and constant walk to the front where the destination is. This is how we look at large and long description of words and just reduce it to a simple graph, which we call distance time graph. Take note that our y-axis is our distance, this one here. And we call it distance in kilometers. And our x-axis is our time. It could be in hours or just labeled. Now, let us look at this through a diagram which will be describing these various situations at every point. Now, this is a distance time graph. On the y-axis here, we have the distance, which usually depends, it can be in kilometers, it can be in meters. And then on the x-axis, we have time. Now, from what we have just seen, we should have realized that when we have a line, and I want to cite two areas. between the area here and another area here, these two areas displays what we call constant movement. There is a constant movement between here and here. The same constant movement can also be seen here. Right? So when such situation occurs when you are drawing your graph, automatically I'll know which part had a constant movement. I'm able to see that we have the point labeled A, the point labeled B, and the point labeled C. There is a constant movement. Then there is a point where our graph is horizontal. It is parallel to the x-axis. At this point, we have two areas. We have this one here, and we have this one up here. These points here is the situation when the body is at rest. So when the body is at rest, we can simply identify that. So how do we describe the movement of an object or simply a person? Here, this graph is telling us how the object arrived at a point or went to a certain point, reached its, this is actually the maximum it reached, so this is where the destination was. This is a return journey. Because by the time we are here, the distance is 0. So this person went and came back home. But if the situation would have continued like this person did not come back home, then we would have expected further, I'll call it, I'd have called it further movement. Where in this case, you traveled, stopped, traveled, stopped, and traveled further. That is how this graph is supposed to be looked at. So now let us look at a few questions and see how to answer questions on graph. But before that, what do we need to understand about the graph is this. When you look at this graph, it is divided into segments. It consists of what we call line segments. And I've labeled line segment, one of the line segments is A, B, and C, which signifies a constant movement. Another one, if I am to label, I'll put an I, Roman 1 and Roman 2. It signifies rest, and that means there was no movement taking place at that particular moment. So I want us to also understand that each segment has got a meaning. Like one segment is telling us constant what? Movement. Another one is telling us there is no movement, there is just a rest. Those are segments. Now, I want to put this clear. We all know what a gradient is. A gradient is simply steepness of a line. So, we are saying today that the steepness of this graph represents their their speed, in other words. And we mean that the steeper the slope, the greater the speed. This thing will tell us. You look at it and say, this person was driving at a very high speed. You look at it and say that this person was slow. Why? Because you are saying, if we have a steeper graph, then you are driving fast. If your graph is gentle, then you are driving slow. So you can guess where you are, given that you can be able to drive. Where do you belong? Are you in the steeper segment, or gentle segment, or just flat? We are saying that the horizontal line, we have looked at the speed steepness, but now the horizontal lines 1 and 2 means that the object or the person is at rest. Or we can say that the object is at a stationary point, or it is stationary somewhere. And in general, the volume of the speed remains, and we say speed we are saying speed is equals to distance traveled over time taken. So, to draw a graph, we shall be required to simply use the values that we have been given. And in this case, the distance will go to the vertical axis, while the time will go to the horizontal axis. Now, we have a graph here. This graph is a distance time graph. On the y-axis, we have distance, and this distance is in kilometers. On the x-axis here, we have time in hours, that is first hour, second hour, and third hour. Using this graph, we have been asked to simply answer the question that follows. Now, the distance time graph of the journey has been shown below by the graph from point A to point B. And the question that comes, the first one is that, how far did the car travel? How far did the car travel? For us to find how far the car traveled, at this point that I call A, the kilometers is 0 kilometers. And where it is ending at B, as you can see, it is what? 300. It is 300 kilometers. So when you are asked, how far did this particular car travel, then it's very simple, because looking at the total journey, we have this as 300. That is the total, and where we started is 0. So it is 300 minus 0. That is the distance at B minus the readings at A. That gives us the distance of 300 kilometers. So there's nothing wrong about that. And then now you go ahead and look for the next question. How long did it take the car to complete the journey? To complete, we look at where we started from. It was 0, then 1 hour, 2 hours, 3 hours. So it is taking 3 hours to reach the point what? B. So the answer here is 3 hours by counting what we have. The last question. What is the average speed of the car? What is the average speed of the car? And the average speed is given by S is equals to D over T. So our average speed is equals to D over T, which is equals to, in this case, total distance traveled, that's what D stands for, which is 300, divided by total time taken, 1, 2, 3, which is again 3. This one gives us It gives us 100 kilometers per hour, because total distance is 300, total time taken is 3. And you divide, you get it is 100. Now, in this question, we are going to use this graph that we have to answer quite a number of questions related to time graph. So we are told here that the distance time graph shows Noah's cycle journey from home one morning. And they are asking us, find Noah's speed in the first hour of the journey. Find Noah's speed in the first hour of the journey. Now, let us study our chart here. You realize that what we have is as follows. What we have here is as follows. We have this axis, which is for time. The axis here is for time. In time, we are starting from 6 a.m. to 7, then to 8, to 9, to 10, and up to 11. The y-axis, that's the x. Y-axis, we have distance from home in kilometers. And distance from home, before you start leaving home, you've started at 0 kilometers, then to 10, then to 20, to 30, 40, 50, and so on. So, at this time now, let us look at the question and see what does it want us to answer. The question is asking us, find Noah's speed in the first hour of the journey. To identify the first hour of the journey, it is between 6 and 7. If you are very keen, it is here. That is the first hour of the journey. And so we stop at where the hour ends, follow the grid until you arrive. So you see, you have a point here. This point signifies the first hour of the journey. And you'll notice that after this, Noah chose to rest. So the first hour of the journey, if they are asking find Noah's speed in the first hour of the journey, then we need to use the know that the speed which is given by us is total distance traveled over time. By the time we are taking the first break, how many kilometers have we traveled? So this is 20, this is 30. In between is what? 25. So it will become 25 over total time taken. This one they just told us straightforward. The total time taken was 1 hour. The total distance covered is 25. So it is already per hour, and we have 1 hour. Therefore, the answer should be S is equals to 25. We have 25 kilometers per hour. This is the speed of Noah in the first 1 what? 1 hour. So that this question is done. We identify the point. Let us look at the second question and see what it needs. So we look at the question here. It is asking us, how many minutes was Noah's first rest break? Now, when you talk of rest, I've already illustrated. The moment you see on a graph, distance time graph, an horizontal line, that one you are resting. So in this case, they have said the first rest, meaning there is a second rest, but let us look at the first rest. So the moment the journey begins here, when it reached here, something happened. I told you when we have an horizontal line, it doesn't mean anything. It means only time is moving, but distance is not moving. So there is a constant there. So if we are to use this constant here, we should first identify what constant is this. Can you be able to partition this graph according to line segments, each meaning whatever you want to find? So for this case now, we have a segment coming up here. This segment is a rest. The same segment is showing has shown itself here. This is also a rest. So when you talk about a rest, our question is asking the first rest. The first rest before break. So break is coming later on at about 9 something. So the first break we have here is simply between 9 and we have 9:45. So for us to find what is the break is, take the last time we have, which is going to give us 7:15. Less the former time, which is 7 dot. So 7:15 hours minus 700 hours, you will find is only 15 minutes. It is only 15 minutes. So we find that between here and here, it is 15 minutes. How did we arrive there? There is a very important key point we need to know. We must know the key, the nature of the key of every graph. For example, this key of hours, on the x-axis, we are saying take note of that, every one small box, which when I say small is here, it represents 0.5 hours or half an hour. So 2 boxes represents 1 hour, 1 hour. So we are able to identify the key. Then again, I study the key of the y-axis. Y-axis has got 0, 10 up to 50. I don't know what it is, but they have said here distance from home and it is in kilometers. So if this one is in kilometers, this one is in what? In time, as written here. To find a resting place, be conversant with the key, and so that you can be able to know what value you estimate, what value does that mean. So I was saying the smaller one is 15, 30, 45, reaching here, 1 hour gone. And then you go 15 again, 30. So this is 15 minutes gone. That's what we are looking for. When they ask us for how many minutes was Noah's first rest break. We are saying it was how many minutes? 15 minutes. In this question, we are asked to find the speed, that is Noah's speed, between 7:15 in the morning and 8:30 in the morning. 7:15, when you look here, this is 6, 6:15, 6:30, 6:45, 7:15. 7:15 is when the rest was ending. So they are asking between 7:30 and 7:15 and 8:30. 8:30 is here. Yes, another rest began from there. So together, when you want to get the speed here, we need to look at this graph between these 2 points, look at the steepness, and use the knowledge you know about the gradient, and you find the speed. So the speed here is going to be given total distance traveled over total time. Right? How do we get our total distance? It is easier. Look where we started from 7:15 is here. The distance is 25. We have stopped here. The distance is 45. So take 45 minus 25. So distance traveled, S is speed is equals to distance traveled, which is 45 minus 25. And then this is the distance over time. What time is it there? Is there between 8:30 and 7:15? You realize that time is 1 hour 15 minutes. 1 hour 15 minutes. 1 hour 15 minutes is the same as 1¼ So this is the distance, which gives us 45 minus 25 gives us 20 over. Now this one is 1¼ is the same as 1.25, I want to believe. Or we just use the normal improper fraction. This is simply 7, this is 4, 5 over. So 5 over 4. So when you are dividing, it's the same as multiplying by the reciprocal. So this is 20 multiplied by 4 over 5 by 5, 1 by 5 by 5, it is 4. You get it is what? 16 kilometers per hour. So it was important using your eyes, study the graph, identify the areas of need, and know how to subtract. This is ordinary algebraic expressions and integers. We just deal with them. Having known that this one, the change along the y-axis is representing the distance, and the change along the x-axis is giving us the time in hours, then we go ahead and do what? And simply subtract, get the distance, and divide. So Noah's speed between 7:15 a.m. and 8:30 a.m. was 16 kilometers per hour. So we are seeing Noah again resting for the second time, and that's why this question here is asking us to find what time did Noah start and finish his second rest. Let us again take a look on our graph. We are going to concentrate on our second rest and see what time did the rest start and what time did the rest end. And you realize that the rest comes under here. We started from here and ended here. We follow the grids here. When you follow down, you find this is 8, this is 9. It is between 8 and what? When you look at this, it's between 8 and what? You'll be comfortable. You see, it's actually between 8 and about and 10. So then we go for exact value. So at the point here, then we go down. Let me call this point P. If you follow it, you'll find that you'll come down all the way until you find starting time 8:30. So I'll write down start. Stop time after rest, we come identify here, it is between these two boxes, and define this is what? 9, I'm not wrong, 9:30. So, we need to clarify, this one is 8:30, and this one is, this is 9:15, not even 9:30. It's 9:15. So when you look at this, the question is asking, at what time did Noah start and finish his second rest? They have not asked us for the duration. They have only asked us to look at the graph and tell us, what time did he start rest? We have said it is at what? At 8:30. What time did the rest end? And the rest ended at 9:15. That is it. Next question. Now, we are going on with our graph. The major thing is learning how to interpret the graph, identifying the line segments, and giving reasons why that graph looks like that. So this question is asking, at approximately what time had Noah ridden a total of 65 kilometers? Now, you see, before any journey begins, every journey must begin from zero. And that's why in our graph, it is starting from the origin, which is zero. So they're asking 65 kilometers. 65 kilometers. So when you look at this issue of 65 kilometers, let us start from here. The moment we move and reach where we have the first rest, we have covered 25 kilometers. So the first move before rest, we have 25 kilometers. Plus, second one, we are starting from 25 to 30, 40, 45. So this is 1, 2, this is 20. So we are adding again 20 kilometers. This is not enough. We move ahead now again. And now, from here, we have a kilometer of 45 at 45. So to here, it is 10. How much do we need? 10. This is a 5, 10, 15, 20. 20. So I think we are talking of somewhere here. 20. Let's see, when we add 20 kilometers, do you get 65? 25 plus 20 plus 20, that is 65. So we are trying to find out what time was it when Noah was riding past this point here. So you to read this point, you go down. You see, I'm reading 10 a.m. 10 a.m. How did we arrive at 10 a.m.? We looked at the first break was taken after 25 kilometers. Second break was taken after 20 kilometers. Third break, there was no break. There was just a constant move up to the end. But we have looked for only 20 kilometers so that we can fill up the remaining to 65. Therefore, we shall say at what time will Noah have covered 65 kilometers? We shall look at this point and we say by 10 a.m. Noah will be through with 65 kilometers. Now, we need now to look at the return journey. Find Noah's speed on the return journey to 1 decimal place. Now you see that as much as we are looking at the graphs, it is also reminding us about fraction. It is also reminding us about decimals. So the question here is asking us to round off to the nearest 1 decimal place when we look for the Noah's return journey. The word that is very, very important here is the return journey. And we only start returning having reached the top. Looking at the graphs we had about the classroom, those ones who were starting to walk from the front, we were drawing the graph from the front towards back. Meaning there is always a limit up there. So here, the moment Noah attains at this point, there is no longer acceleration. You will only rest and then start coming down. So, the question is asking for what? The speed of the return journey. The speed of the return journey will be taken by change in the kilometers or the distance up to the end. So I'm looking at 0 to 45. So we are talking about total displacement or total distance as 45 kilometers. Then we go into time because speed is equals to distance over time. We go into time. How much time elapsed between this part here to end here? This is 11, and when I follow this one, this is 9 what? 9:15. So we talk of total time. We have 11 minus what we have here is 9:15. We are to subtract this, which we can do it logically, mentally, or go and even count. If you choose to count, you see, we shall assume this part, we shall take this is 15 minutes, and this is 1 hour. So we are counting this is 45 minutes, and then we move plus 1 hour. So we are doing 1 hour 45 minutes. So in this case, if it is 1 hour 45 minutes, what are we referring to here? Because this is 1 hour, this is 1 hour 45 minutes. Convert that 1 hour 45 minutes so that we can work out. So our question now is speed, which is S, is given by d over t. And our d is 45. And our time is 1 hour 45 minutes. That is the same as 1 hour 3/4 of an hour. So it is 1 and 3/4 hours, which can also be converted. We are talking about time that is we look at 1 and 3/4. That's the same as 1.75. But let us do it properly. This is by 4 is 4 plus 3 is 7. 7/4. So down here, these are hours. Up here, what we have there is what we have up here is kilometers. So the moment you divide this, you will get what we need. Or alternatively, those you can use a calculator and get 45 kilometers divided by 1.75. This is hours. So let us look at a calculator and remember, give our answer correct to 1 decimal place. Let us use a calculator and divide this and we get. So they said we put our answer correct to 1 decimal place. When you place your calculator, you'll find 25.71 something so on, but that's not the interest. We take 1 decimal place, look at the critical digit and the rounding off digit. You will find that it is 25.7 kilometers per hour. Now this one is the speed of our return journey, the return journey for Noah. Okay, still looking at the same now. We want to wind up and see the whole journey. How do we simply approach this graph as we look for the average speed for the whole journey? Take note that when we talk about average, some have a tendency of going to remove the rest. Here, we are going to handle it irrespective of whether you rested or you didn't rest. It is just a matter of the total distance that was covered when you began the journey up to the end. And then you come and look at the total number of hours you took. So let us look at the last question on this graph. Now, looking at this question, what was Noah's average speed for the whole journey? Now, when you talk about the average speed for the whole journey, this one inclusive is when the speed is movement is constant, when there is rest, whenever, even if there is a breakdown and so on. We normally look at the total distance covered over the total time taken. So the average speed this average speed is total distance over total time taken. Strictly that. No compromise on this. Therefore, looking at the graph, and the answer should come from the graph, not anywhere else. What is our total distance? So let us first see how to come up with the total distance. Now, this journey, if you look at it closely, it has got two areas. It has got the first part where it goes, reaches where the destination, and then starts coming back. Coming back is not the fact that we have gone there. It does not mean we didn't come back to the destination. Only that time was moving. Otherwise, this person has gone and come back home. That's what we're saying. So there are two areas. The total distance covered to the place, and then the distance covered from the place back home. If this person passed somewhere else, then we would say Noah passed somewhere else, so we again add more distance. But here it is telling us, for Noah to start turning back, he had covered how many kilometers? Let's see. From 0 to 50 minus 5. 45 kilometers. These 45 kilometers, it is to the destination. Then he turns back and starts coming back. Where he didn't rest, he came back straight. And this one will give us plus another 45. I have not assumed the 45, but I know the distance you cover as you go will be the same as distance covered as you come back. That's why we have 45 to the place and 45 back. So what is the total distance covered here? It will be 90 kilometers. Now, when we talk about total time taken, I don't need to make this mistake. It is a matter of when did he start the journey and when did he finish the journey. It is not that when he started the journey, how many times did he rest? How many times did he have breakdown? No, all that time is counted to be the total time. So for us here, it is very easy. We are not going to go into details of these line segments, but instead, we are only going to look at strictly the time when Noah started to travel to the time when Noah reached or arrived back from the journey. That is the total time taken. And from here, you will see, started from 6 a.m. and came back at 11 a.m. This is 11 a.m. 6, 7, 8, 9, 10, 11. So 11 a.m. minus 6 a.m. will give us number of hours. And you'll find that total number of hours is 5 hours. That is 11 hours minus 0.6 hours. You'll find it is how many hours? 5 hours. So if it is 5 hours now, that is 1, 2, 3, 4, 5. Then the speed S, average speed S is total time taken for which is 90 over the time taken which is 5 hours. And when you simplify this, you'll find that what you get is 18 kilometers per hour. 18 kilometers per hour. So in today's lesson, you must have seen something different, something about interpreting a graph on distance time graph. You have seen that when you have a graph of distance time graph, you can come across so many questions and you answer. It only speaks out, but in form of a diagram. At the same time, we can have this long statement and we present it on the diagram. As we end this lesson, I want to believe you will not have any problem on interpreting a distance time graph. Otherwise, for this, we should be able to know how to convert. Be careful, as I told you, study the key of the graph very well. That's both the x-axis and the y-axis, and use the key to know how well to answer your question. That is it for today. Thank you.